Hello Calculus student, this video is for chapter 5.6 part 2, looking at how to do integral involving exponential and log function. And in particular, in this video, we're going to do definite integral. So that means we will just use change of variable. We never go back to x after we change it. So remember, so let's do the first one. And then the strategy is whenever you see something in the E that would be a good candidate for being u. And then if you do like a denominator with nothing, with not square or root, then this would be also a good candidate of u that would end up in ln. So the first one, this one we don't need to do u because it's just kx. So the integral would be e of negative 2x over negative 2, right? So it's just a basic integral formula. But then we evaluate from 0 to 1. So that would be you can do the negative 1/2 outside, and so e of negative 2 minus e of 0, right? So that means negative 1/2 1 over e squared minus 1. So that is 1/2 minus 1 over 2e squared. Okay, so for exact value, you just leave it that way. The second one is from 1 to 2 for x e to the x squared. So obviously x squared would be our candidate for u substitution. And then you can see that 4x dx is waiting outside. So du is 2x dx. So we just, if we multiply it by 2 on both sides, you would say 4x dx, right? But then because this is a definite integral, we have to change the u of 2, change the a and b also, would be 4. And then u of 1 would be square of it, that's 1. So now this whole integral now change it into 1 to 4. E of u, because 4x dx is du and du. So it will be e of u 1 to 4, and we don't need to change back to x. So it is e to 4 minus e of 1, which is 0. No, e of 1 is e. So e of 4 minus e of 1. That's the answer. And the next one would be, so now this kind of things, if you do it in decimal, they might not give you the exact answer. They will give you, we can try 4x e of x squared dx 1 and 2. You would see that why you still need to learn how to do this. Get rid of all this first. Do function, we do miscellaneous integral. What was it from 1 to 2? 1 to 2. What is it? 2x? Or is it 4x? 4x. I forgot. 4x e of x squared dx. E of x squared. So dx. So they can give you a number, but you would not know, right? So, but how do I check that it is right? E of 4 minus e of 1. E to the 4 minus e to the 1. Oopsie. Oh, it is not correct. What did we miss? I think we missed the 2 maybe, right? Because when we write du, it should be 2 here. Right. So let's check. If I multiply by 2, would that work? Maybe. If I multiply this by 2, so do a parenthesis of 2. Because that doesn't work. So it's, yeah, you see how, that's how you know that this answer is correct. But if you don't go through your real substitute integral method, you would not give this exact answer. This is the exact answer. Okay, so the calculator can help you a little bit to check your answer, but you still need to do your work for exact answer. So this is a denominator with one thing, so that's our candidate for u. And then when we do the integral, so we say x squared plus dx. Do a differential, du would be 2x plus 2 dx. Do we have that? We have 3 plus 3x. Oh, if we divide by 2 and multiply by 3, then maybe that would work, right? So 3 over 2 du would be 3x plus 3 dx. That means you divide by 2 first on both sides, and then you multiply by 3. So this would be replaced that way. And then we have to replace the 2 and 0. So u of 2. If we plug in 2, it will be 4 plus 4, 8. U of 0 is just 0. So our whole integral now change into a 0 to 8. The top would be 3 over 2 du, and the bottom is just u du. So that would equal to 3 over 2 ln of these things x. Oh no, we don't change it back. Ln u plus c. We don't change it back because we have changed everything already. So 3 over 2. Oh no, plus c. From 0 to 8. 0? Does it work? Ln 0 is undefined, so it's not a very good question. Maybe I'll change it to 1. I'll change your answer to 1. So u of 1 is what? U of 1 is 1 plus 2 is 3. So we should do that because 0 is not defined. Oh, actually, yeah. If you, in the original function, you put 0, it's also not defined. So change it to 1. I'll change the notes to 1. So, oh, this is 3. So I would do ln 8 minus ln 3, right? Ln 3. So you should combine this together. The ln subtracting is divide. 3 over 2 ln 8 over 3. This is the exact answer. Ln 8 over 3. Let's check 1 to 2. Let's check 1 to 2. Yeah. And then 3 plus 3x. 3 plus 3x over what? X squared plus 2x. X squared plus 2x dx. So we have this. Would that fit our answer? Our answer was 3 over 2 ln 8 over 3. 8 over 3. 8 over 3. Exactly. So this is a correct answer. So example 4, the next one is from 0 to 4 tangent x dx. How do we do tangent 4? Remember we say tangent 4 was, well, actually there's tangent 4 was sine x over cosine x, right? So our u would be cosine x, and our du will be negative sine x cosine x, oh, negative sine x dx. And then we would do change by pi over 4, so cosine pi over 4 is root 2 over 2. Cosine 0 is 1. So our integral would become like that. Would be 1 in the bottom, and then root 2 over 2 in the top, and we have negative du over duu. So that's ln, negative ln absolute of u, but plug in with root 2 over 3, root 2 over 2 and 1. So it is negative ln root 2 over 2 minus negative, that means plus ln 1. ln 1 is 0, so it's this one. So in a sense, that would be ln, negative means reciprocal 2 over root 2. 2 over 2 is ln root 2. That's the final answer. Okay, so you change everything and you just do u. When you do in definite integral, is actually easier. What problem? So this is a review of the net change theorem. A population of fruit fly increase at a rate of 2 e to the 0.02 t flies per day. So this is not describing the population. This describes a rate. And you want to know how many there is in 10 days. So let's do from 0 to 10. What is the net change? Right? The change is from 0 to 10, the rate, which is 2 e of 0.02 t dt. And so that would be what? We don't have to do those use substitution. 2 e 0.02 t divided by 0.02. Okay. And then from 0 to 10. So that means so divide this 2 divided by 0.02 is 100. So e of times 10 is 0.2 minus e of 0 is 1. So that is 100 e of 1/5 minus 1. Okay, so we can actually put in the calculator and find out what it is. 100 e of to the power 1/5, 1/5, and then down minus 1. So it's 22.14. Yeah, times 100 is 22.14. So the change would be in 10 days is 22.14. Let's say 22. In the beginning, there were 10. No, in the initial is 100. Where does 100 come from? So what is the how many there are there now? So the new number of flies would be 22 plus 100, or 100 plus 22 is 122.